Welcome everyone to our live T2 Linux and Fixing the Open Source Landscape YouTube channel. We have our Linux distribution kinda ready for release. Actually had lots of things already tested, and then viewers found out some of our ARM images are not fully working. As usually, the only substitute for testing is more testing, and to my surprise, how should it be differently in 2024? The Free Software Foundation GNU people decided to install their GCC now, strangely wrongly, as senior on ARM, unless x86 or other PowerPC, Spark, MIPS and so on platforms. We historically had no multi-lib, meaning libraries in lib and user lib64. And due to that, the default library name, because there was no multi-lib, was lib and not lib64. And that's also what the glibc has hard-coded. And I mean, not only that, some CPUs like Apple Silicon do not even, I believe, cannot even execute the legacy, old-fashioned, differently complex 32-bit ARM code. There is GCC does not even support. The last time I checked last year, unlike other architectures, like most other architectures for ARM, maybe because ARM64 previous video instruction set architecture is slightly different, and although that didn't prevent people from implementing crazy complex stuff for x86, GCC does not even support with one compiler targeting both, right? Huge complication. That means for emulation stuff you need two different GCCs around. Super annoying, whatever stuff. Yet I'm shocked that the only constant is change and regressions GCC now installs, despite V correctly, I checked this before the video, vconfigure, that's all the complex stuff that we do for 25 years here, right? Now live on YouTube. We even tell GCC, hey look, we want to disable because we know, like, we need to do this for 35 architecture variants. So we know with GCC always doing their own thing and stuff. We tell GCC, hey, we really definitely, please don't give us multi-lib, disable multi-lib, right? And what does GCC do? It's like YOLO whatever, multi-lib. You said no multi-lib, you get it anyway. It's like due. Like even recurring theme, debugging, configuration, makefile and other complex nonsense. Even the GCC people do not know what they are doing, which is crazy because this path is hard-coded in glibc. So glibc is actually storing the dynamic linker path in the ELF libraries as ARM, as just here, libcso, right? Oh, this is also not that one, but any like bin bash as libld. So glibc, like it is, like we have only one architecture variant, which is 64-bit. So like Itanium or RISC-V for that matter, kind of sorta mostly, it's like /lib, right? And the GCC people, YOLO, you asked for /lib. We know it better. You will get, scrolled over it. You will get lib64. It's like, yeah, thank you very much. And then you get some strange, why do they do this? I'm not sure if that was last year the case, so I would need to go to the archive and back in time, but basically YOLO, we will just fix it. So how we will fix it? What's the configure? Like we will patch that away in one way, shape, form or another. Because the thing is that it's mostly usable. Unused, I mean, I wonder why why do they bother by default? Sure, they now support, apparently maybe that is new. If you are now more into this implementation details, at least I didn't see it recently. So maybe it's new since with GCC 13 or whatever. So why we did test suite, right? If you don't have a test suite for that, people do random shit, like in the Free Software Foundation. It's like, yeah, it's probably why they don't have their microkernel. That is heard ready anyway. So what that is ILP32, that is int long pointer 32-bit for better cache efficiency and whatnot. But basically, nobody probably is using it. I mean, theoretically, we could support that, but that's not what we have asked for, right? We have asked for disable freaking multi-lib. Maybe we can work around that with forcing, for some architectures, we do that already. So for H, for example, that would be config in. So that is, nobody's using it. except maybe some data center where usually you have more memory. So maybe not even in a high-performance supercomputer data center, they're using it because they're most likely they need more than 4 gigs of memory, because with ILP32, similar to old-fashioned 32-bit stuff, which we wanted to get away with, you can only address 4 gigs of memory, right? So I have no idea, like, unless some very specific embedded thing. Sure, we do this for our vintage and retro stuff. We do this on Spark and MIPS and PowerPC for our beloved P3 and GS5, because usually you don't have that much more memory on a P3 or G5 even, and want a little bit better performance also on SANE Ultra Spark. So there we do that. So yeah, I wonder if we can force it like that. Maybe not. So most likely we will end up debugging this anyway. So this is a T2 config to force multilib stuff. I'm just not sure if this will have an effect if it's empty, because this is obviously Super H, Dreamcast and other such car entertainment and vintage gear specific. Let's maybe check actually GCC multilib, because we have here if, yeah, so that is non-zero. So this is so I hope we built Super H, right? Of course we built Super H. I'm surprised that all my patch rate just builds by default now, but it's probably 25 years of patches and eventually stuff actually builds. We could test if we just copy that here for a quick test before we further, because I'm not sure if this has a chance to do something. If we're lucky, this disables it, but if we're unlucky, this does not disable it. This kind of stuff you don't find in a freaking manual. The manual will say this specifies a multilib list, but whether it works if it's empty or other such stuff. Should we run? I mean, we need to rebuild everything at the end anyway. Let's quickly, I mean, we could directly build 2 GCC actually, but do we have that in here already? Multilib, because it is faster to build. Actually, that is interesting here. Oh, no, it is here already. So this stuff is crazy complex. I know that already. This is absolutely disgusting shell scripting and makefile hackery. And I debugged this once. I remember I absolutely hacked and patched the heck out of this shit for Spark64 because I wanted it differently than they do, or maybe even MIPS or both. And I remember it was totally cursed. And no, I also cleaned the wrong. So let's try 0 GCC just because it's faster. And yeah, so many things, and that's the thing, right? Recurring theme is so many things in IT are cursed, even open source and stuff. And I really wonder, I mean, this stuff is not that complex, right? But the GCC developers made an absolutely cursed, this is also, speaking of absolutely cursed, there's also a typo there. Thankfully didn't. So they made an absolutely cursed mess out of that. Which again, it took me 8 freaking hours to... why did this not... here, because that is a double. Thankfully this is not committed, I only had here. Oops. This was not yet committed, no harm was done. Yeah, the GCC developers made an absolutely cursed stuff because it's a make file, it's a shell script, it's configure stuff, it interacts strangely, then the multilib build stuff, and then it's, I believe, reading in what it's make file shell scripts which are already unreadable cursed, and then the stuff reads in what GCC outputs again, just for memory when I debugged it over a year ago. Absolutely cursed shit, absolutely ridiculous. Also, we're not building with all cores from the all embarrassingly parallel build all thing. Yeah, that is why we sit here all day long and fix stuff, right? Because that is the state of IT. ARM, that's also wrong build. ARM64. Let's track the log while it's still building. Multilib, does this already change? Disable, okay, the set is empty. does this? Somehow there is some X-trace on. Oops, there was, by the way, the multi-lib list. Multi-lib. No, yeah, as expected, that doesn't change a shit. We can already, it's like, yeah, why do you have ignoring configure options, and why to have configure options to ignore them anyway? Thanks for nothing. I mean, except thanks for the free compiler. Highly appreciate it, but yet somehow I find myself weekly patching this stuff. Ironically, for Super H it works. As like, yeah, for Super H, probably I made a video 2 years ago. For Super H, the defaults are even crazier and even more cursed. And our hackery and patchery is similar cursed. I mean, and for Spark, we also fix it. So, or like for Spark. I mean, I said this even just the other week, right? Even for MIP64, they have crazy. Why they need to have such crazy defaults is really beyond my understanding. For MIP64, they also built 3 variants. Normal, or like old 32, 64, not sure if that is called N64. So old 32, N64, and N32, I believe, or whatever, which I just said the other week. You don't need all of them. I just said the other week, nearly no Linux distribution, even supporting MIPS, would ship that like that, I guess. I mean, the only thing is enabling that to have test coverage, right? The only argument for enabling strange stuff, I mean, enabling strange stuff by default, that nobody's using it like that, and then enabling the default configuration to be unusable for everyone. It's like, yeah, that's free software foundation GNU quality at its finest. We can control C that already because we don't need the whole build anyway. What did I want to? Did I want to diff that? All right, did I not yet commit that? Potentially, maybe. All right, I wanted to. That is what I wanted to check. I wanted to check ARM64 whether we. Didn't keep an error. That was not very smart. And what else did I? I believe there was other extras. So this is deleted. Thank you very much. My infinite cleverness. But again, we don't need the full build. We will start debugging this in a second. I only wonder slightly. I saw there's some X-trace. I slightly wonder where the X-trace was coming from. Apparently not from. Not really sure where that is. Maybe it was slightly touched somewhere. Good. Control C. Let's see where we need to patch that away. So what we will basically have to do, because disable multilib doesn't work, we will just patch it. Like 2024 configuration. I mean, that's even not new Meson or CMake. It's old-fashioned autoconf stuff, and even that is cursed. And I mean, obviously, cursed and not working. It is ILP32, I believe it was. That should be in config Aarch, maybe. Unless it might also be in others. By the way, here is, so it's 2017 Aarch. So yeah, so they implemented that somewhere 2017. We could even check. Maybe we find here multi-arch for ILP32. Okay, it's actually 5 years old already, or something of that sort. Handle LP better, handle LP 2000. Maybe that's something else. Anyway, so that is config Aarch, maybe. Maybe because it might be somewhere else. Yeah, and so this convoluted stuff we need to patch dynamic linker, which is absolutely crazy that they have here. So that you see here already Musel, so that is here glibc. So they have here. So they even. I anyway hate this having the dynamic linker. So they just append here maybe. So yeah, they just ILP. I mean, yeah, they have the. I would hate that anyway, to have the libs in lib64 and the bloody dynamic linker in lib. Like, who in their right mind sets it up like that? It's hilarious. Here's also multilib. Let's see how much we need to patch. We need to at least patch this. I have already experience with it. So here's multilib. So Aarch if def target yada yada then be okay multilib OS tiers. ABI, so basically call if Aarch be OS dear name. Somehow this multi-lib OS dear names ABI LP64. I mean, basically, basically we want none, right? ARM. How to define? Does it need to be empty? Because maybe it needs to be empty then if you want to fully disable that. Have I ever fully disabled this for something? I mean, thankfully we have an Epic Threadripping Horizon. We could quickly build that. Although I believe it can be empty, right? Call if multi-arch. Where would it even... Or is that an additional... Do they have an additional config option for... If you're building B-arch or multi-B-arch, combined tree, code sign, GCC install if you're 32, building B-arch multi. So that's only in here. Maybe, do I patch that away from any other? Spark we modify. Maps we modify. Where is even this scan multi-lib? Define multi-lib Aarch multi-lib IBI name. I'm only looking a little bit around, I don't want to build this 5 times, better investigate this 5 minutes longer. Multi-lib, if target big end, return IP arch or Aarch. I have the impression this will probably break as usual easily. Again, it's not. What I usually take a look then in surrounding things here, multi-lib option, dear name, setup, multi-option, RTP. Maybe some BSD. Do they have this nonsense too? Okay, they simply don't have that defined. Lib 1, then range. If yada yada. I'm somewhat inclined to try to commenting it out fully. If we are lucky this works, if we are not, we need to. Because I think it could be empty from my past experience, but let's see what happens. Could fail quickly, it could build, it could require further patching. Only a trial will find out. And that is even, I mean, I would need to study even more of the build code, right? Like this is why I mean, without past experience, you could easily spend an hour or an afternoon on this stuff. I already have touched this stuff often enough. But even then, I never deleted it completely away, I believe. Multi-lib. What did this generate? Somewhere, where did this Xtrace? Ah, right, I know where this Xtrace is coming from. I know where I put this in. Okay. It now generates, so maybe it worked. That was easy if we... The question is, does the Linux kernel build? And I hope they don't build crazy... I mean, the ridiculous thing is the one like basically this ILP32, next to nobody wants to use unless they want to tiny optimize their performance, marginal performance PinePhone or stuff, or PineTap or whatever. Like get, I don't even know what, a %, 2 or 3, like maybe we should actually benchmark that just for the freaking fun of it. Or actually leave in the comments below, should we actually support this stuff? Like maybe for stuff like for the PinePhone, how much memory did this PinePhone have? 4 gigs? By the way, do they still sell that, or do they have a new one? Do they have a refresh? I actually didn't follow that at all. I only, thanks to an amazing viewer donation, I still have this here for testing, but the performance was of course a little bit lacking, right? So I wonder, or did it even had more than, oh no, 2 or 3? I mean, yeah, we could make this a 36-bit configuration of supporting Aarch64 with 32-bit user space. Cool, let's build. Do we need to build it? Or like, you know what, maybe we actually better build all in order, not to course here. So yeah, maybe it worked. That would be amazing. Slightly faster than expected. But that's what we code all day. Like, if you're wondering what do we do all day, that is what we do all day for us, ourselves, and you and our customers. Fixing stuff every day. Yeah, sometimes stuff is surprisingly easy. The question is, does it break something? Maybe we check actually our... Because the thing is, maybe the Linux kernel doesn't build it anymore without this nonsense, which, I mean, we could also change the multi-lib stuff. What I do for other platforms is change the names, how we like it, like how they are SANE, not how we prefer sanity, to restore sanity. Freaking windy outside though, if you want to know. Nicely globally warmed winds. Sounds like the roof flies soon away. I hope not live on stream. Would be pity for all our precious hardware. What did I want to check now? Said, all right, I wanted to also SVN add that. All right, this is what I wanted to check. I wanted to check. Okay, let's first SVN add this. That is ARM no multi-lib. I wanted to check the kernel config, whether they, because actually kernel config or log, maybe actually check the log, because config might be not easy to see, or not, maybe they don't have a config, I don't know. But the log should show us instantly whether they have user space VDSOs, VD. Do they have an ILP? Do they have even an ILP32? Oh fuck, they have. The question is this an ILP? So, I mean, maybe they have configurations to not build this if the compiler doesn't support it. I mean, the compiler could still support it, not just not have the GCC stuff for that. So yeah, from the name as usual could be better, because so I slightly wonder if this is, but I mean, I guess that, but this, I would think it could not be a 30. Like what would be, what you would expect is ARM32, good old-fashioned ARM stuff, but the last time I've seen the compiler cannot build that in one compiler. So I would not expect that to be that. We cannot test that because it's built into the kernel, so we would need to disassemble the kernel again. Or when we build this now, of course we build this now, ARM64 Linux, maybe verbose just for the matrix scrolls. And welcome everyone, right? We hope we are online. Is this already, it's not going 1 hour, is it? Why does this say 1 hour? Always strange. Yeah, I mean, maybe the question is, does it need libgcc and whatnot? Okay, so it starts to build. I'm actually really curious. Maybe we actually go in there and... What did I want to... I need to check how much wind is outside. It's a feeling the building flies away soon. That is the Horizon Aero. ARM64. And that's the crazy stuff, right? In my opinion, a SANE distribution using lib, which most people anyway prefer over our standard lib64. I would not be surprised if every ARM64 supporting Linux distribution, which I don't know, might be a handful or 2 dozens of all the 2016 Linux distributions, need to probably patch that, right? Although many others just copy Red Hat. But everyone who does not copy Red Hat needs to patch this, which is absolutely crazy that they... Like, yeah, why we can't have nice things? Why the defaults are stupid and not working, similar to the audio on the Steam Deck, right? Audio, okay, we have audio. So, boot kconfig compat. Do they have here any? Okay, they have a compat. They have even a SAM2 compat version. But they have a compat VDSO. The question is what? Now I'm really curious what they built there. And that is, people always ask, how do I know all this stuff? Yeah, I look for 25 years into all this stuff, so some of this nonsense you remember and pollute your brain with stuff you never wanted to know. VDSO32. So what kind of file is that? I have no idea. So that is 64-bit. So they say here, actually... Right, it's also PA risk. Which did I even... This one, right? Rep-O. Arch ARM64. Is this the full command of ILP? What do they do here? -M. Little Indian. Yeah. I'm actually not really... What do they do here? Save command, KCC. Do they even specify here? No pi, no LTO. Where is even the freaking architecture option? Didn't see it. ILP32. Meter offset, yada yada, compat VDSO. Yeah, what compat is that? ARM kernel. Which other do they have here? I know this is ARM. How is this 32-bit? It's indeed 32-bit ARM. How do they... Since when does that work? And how do they... Same as CC options, target. ARM Linux GNU EABI is Clang, otherwise... We cannot use global Linux compiler DSO files, main reason being 32-bit compiler may be older than the main 64-bit compiler. So they have here too. Where do they get this compiler from? I'm a little bit confused now how that should... The last time I did this, it did not work. Or does it somehow... That would mean... ARM64. Aarch probably, of course, Aarch nonsense. Not invented here, stupid naming. I don't make the rules. Other people have decided such nonsense. Since when? Ah! Do they support this with Arch? I've tried M32. Ah, wait. No, ARM version 8? I'm getting so confused. No, wait, this is the wrong Arch. Version 8 is 64-bit. I'm a little bit confused now how they... Okay, at least GCC built and installed into user lib. Hallelujah. So basically I need to rebuild all the ARM builds, which only takes 3 hours. That's certainly a welcome last minute fix for our increasingly popular Linux distribution where everything magically, by totally not hard labor, is finally working. I'm just totally perplexed. I probably spent, so basically we are done, it works, but I think I will shortly, I want to know how this works now, because I don't instantly see how this works. So this is somehow magically 32-bit files, but... Or how do they... I have no idea. The more you learn. The problem is that they're hiding the verbose build stuff. So, I mean, we could... What was that loud noise? Something from the roof flew away. Welcome everyone for the super chat. Appreciate that. That is comic code. That is the why because I started as a joke because so many bugs that I need some fun on my display to at least to sugarcoat the bugs, but I actually liked it. So due to the irregular, not repeating properties of the font, it actually helps me stare all day long on code. But thanks for asking, hope you like it. Let's rebuild that verbose, so that would be just VM Linux, and verbose is either that or the other. The only thing is, I hope enough scroll back. But comic code is a commercial font, so I actually truly licensed that for the YouTube videos. So VDSO32 AS, what does it do here? How do they magically do that? KCC. But this is also AS. Why do they? Okay, that is actually. I mean, maybe the assembler can do that. Maybe they can assemble, but is this? Do they not have? This is also assembler. Maybe they can do assembly, but not. I don't instantly see there. Where is this freaking coming from? But what is a node C doing? I have not built installed. What's this? R. C. When very limited wrapper things. I'm a little bit perplexed with it. So output, so here they say ARM32 little ARM in the assembler. But how do they build the C files? What else do they have there? Raw. I mean, probably the whole command should be in command, but let's log that here. And that is, yeah, it takes a while to, a little bit extra work also somehow. Why is this not? Actually, I wanted to, somehow we didn't. Ah, we built this with Clang. Ah, dang it. Right, we built this with Clang. Of course we built it with Clang. So yeah, with T2 you get, of course, the highest optimized. Wow, is that hiding the... Wow. So the crazy thing is, we do not even... Okay, that explains the thing probably. With that target, probably they have their target, whatever, right? I guess, probably, maybe, most likely. I wonder then if building with Clang hides that this would fail with GCC. Anyway, okay, it works for me. That is probably good enough. We have, yeah, it would be interesting to see what happens with glibc. I mean, you know what? Let's test that. I'm curious now. I wanna see. Let's we wipe the build anyway. Let's do one more test. Doesn't take that long. Let's swap our Clang default for slightly higher performance, at least on x86. We also need to tweak the ARM. I want to see if that what happens. ARM tools cross bin GCC to KCC Aarch64 Let's do that again. I wonder if maybe this GCC needs a second compiler. At least, as I said, the last time I checked, GCC did not support that. Maybe Clang does. Which is, of course, ridiculous and a shame that GCC doesn't. I mean, I would have never, I mean, maybe, okay, because I would not implement this, right? If I have an ARM compiler, I add the 64-bit mode like they did for PowerPC, Spark, x86, MIPS, RISC-V, and somehow they didn't. Although maybe there are, the only valid argument I could see, which of course now falls on our food, or they were shooting themselves into their food there. Why do we not? What have I done here? Because now they have the issue that so the only argument would have been start clean from scratch, not having to deal with old-fashioned ARM stuff. And now it falls them onto the food. Yeah, sure, they have a more lightweight, no legacy, like all the crazy legacy stuff, right, which is nearly as complex as x86 with different floating point and vector modes and whatnot. Maybe they wanted a completely clean compiler code path without all those legacy, which sure is an argument, but sucks of course if you cannot just cannot just build this code then. Should be ready now. Where's our... Was it already built? Here's some rep. All right. Maybe it's not in there. Let's check in. So maybe it's not in the config log. Maybe the kconfig has detection. Most likely it has detection for sufficiently complete compiler support. Compat. Maybe compat is off then. I don't know. Compat is on though. But did it, so this is finished, right? Did it build a VDSO? No, it didn't. Ha! I knew it. So yeah, there you have it. If you build with GCC, you probably need a second compiler, which unfortunately we also need to have for HPPA ARC64, because as I remember it's similar, but there I can excuse it, although it is also lame, but they're a much smaller team except previously Hewlett-Packard, but keeps maintaining this. So for similar reason you need a second compiler there. Okay, wow, that is, there you have it. If you build the kernel with GCC, you don't get compat unless you have a second GCC, which is silly. Where do they have their compat thing? Compat generic, where would be Kling, where would be VDSO32? Must be somewhere. Generated views objects. Somewhere must be some test for compat VDSO. There is some select, so... Alright, I grabbed for VDSO32, of course, it's named yeah. Compat VDSO. So yeah, CC is Clang. I told you so. Absolutely crazy. CC is Clang and or cross-compile compat. Crazy. Yeah, we could support this. Okay, so there you have it. That's what it is. I hope you learned something. If you don't have a second compiler or Clang, then you don't get 32-bit compat, which granted very few people use, but probably not supported on Apple Silicon as far as I heard. I don't think they implement legacy, which obviously maybe I should check if other stuff like the PinePhone supports it. Anyway, then let's build all of those again. Build ARM, nothing like ARM64 only. That should be 3 builds. And then, but yeah, the more you test, the more you find, the bigger your community, the more feedback you get, and the more people you have actually help you test and report stuff and send patches, packages, new packages. Internal build all, basically, so arches are ARM64, how did I name them? ARC64 Musel and ARM64 Clang, I believe. Parallel 16, Sleep 20 and Tmax. And then in no time, aka in probably 3 hours, we have complete tests and can test that too. We just wait a couple of seconds. This Tmax thing, so this is within 20, so and within 1 minute we will have all those builds running. I think there was probably one more, because if I swap now to the other Tmax to the next window, then it will, my script will place it unfortunately on the other window, and I want this in this window, obviously. parallel 16 so that the parallel builds do not trash the CPU caches that much. Let's just double check that those were the correct names, not that I built here some ARM64 Muso, ARM and Clang. Good, that looks correct. Yeah, the more you know, the more you debug, the more you test. Commit that. Fixed GCC to fully disable multi-lib by default for ARM64 and use lib as configured. Can't mix this nonsense up. A fix a day keeps GCC happy. A day to fully disable multi-lib by default for ARM64 and use lib as configured. Of course, if you want other stuff, you can patch quirk and stuff that risty too. But in my opinion, this is how you want that. So probably the Linux kernel didn't even use it, right? So I'm not even sure if the bloody Linux kernel has. I mean, we could actually grab that. Do they have? Hey, maybe I still have that around if we're lucky. Arch ARM64 ILP. They might not even have any freaking enablement for that. So you have that, like basically the GCC stuff built it by default, and you can probably, as far as I know, not even use it. Linux ARM64, and it's trashing your directories in ways you don't want. I mean, the only thing is if we enable true multi-lib compatibility with 32-bit ARM, we actually would need a lib. We actually would need to build this into lib64. Anyway, details. ILP32. So yeah, as I told you, I slightly wonder if that is, so yeah, as x32, I don't think this is upstream. Or do they have, I mean, maybe they have done something so, no, there's ARM64 ILP32. I didn't grab in. No, oh wait, okay, we can, no, but even with, so yeah, it's definitely not there. But this would instantly match here anything. This also is ILP32, ILP, darn. Sorry, typo. Oh no, there's actually some, but not very much. Why is, oh, this is just crypto stuff. Okay, sorry, typo. Before you yell at people, check your typos. But even then, it doesn't look like that. Where do they have? I would want to see that. Can we fast forward to? Arc? Oh, they have. Why do they patch? Okay, fine, whatever. I don't think it's in there. And we could check what is the Debian progress. Do they even have achieved anything? Fairly experimental, 2016, string toolchain support kernel is being maintained in topic trees, not mainline. The world determines if this architecture gets sufficient usage for long-term support. During bootstrap works, it's possible build. Actual bootstrap was done September. But there was enough breakage interfacing that it was not useful. Congratulations, second bootstrap was done. There's major, tree, branch, pub kernel, branch. Linux kernel, git, git arm. Okay, so yeah, looks old, looks probably, yeah. Anyway, we cannot do, yeah, if we generally mostly maintain stuff that at least once upon a time was upstream or deleted, like Itanium, then we continue maintaining it, but completely unusable, obscure stuff. I mean, just use Apple Silicon or better yet, RISC-V. So yeah, it's not upstream. It makes, therefore, even less sense for GCC. Like, why do they build this? They build it by default and mess up the default configuration. That is a Free Software Foundation experience, like we know it. I hope you enjoyed this, learned something. We could, you know what, let's build this with a little bit more temp FS. Just not to trash my precious SSDs that much. I wonder how much wear leveling they already have from excessive T2 building. Where is the wear leveling? Did I not do? Does this not give you? Okay, whatever. Should this be here? 100% available spares. So okay. I mean, it's not. It's only 20 terabyte. I mean, we embarrassingly tempfs stuff, right? It's only substitute for memory is more memory. So, others, by the way, those, I think once I swapped them, yeah, SN850X, SN850X, are they both 2 gigs? Yeah. So that's even less, okay, that is probably the newer one, so that is only, so written, these are blocks, these are, wait, did I not reformat them? Oh no, this is this format. Why do they divide those by 2? I'm not sure if that is correct. Maybe it is, maybe it isn't. Because it's 4K. I think I reformatted this 4K native. I think plus was plus not the used one? Nah, that is confusing. Whatever. We could check with NVMe control, whatever, but whatever. So yeah, written only 14, so yeah, that's, yeah, tempfs cache, you build stuff, then your SSDs last a lifetime. That's it for this video, unless we want to work live on the other 667 to-dos, but probably not. We want to get this release out. Chances are that this does not fully fix this. It certainly brings us there in the right direction of not putting some stuff into lib64. There might be a possibility that I still need to debug one or another detail. But that's it for this video. I hope you enjoyed to learn something, that even in the most modern GCC stuff, they do strange stuff and you need to debug everything yourself. Although nobody's shipping it like this, because every Linux distribution patches it, probably. Because, like, I don't know, or they quirk and YOLO, I mean, whatever they do, I don't know. But the defaults are not sane for me. So let's take a quick look at the comments. I hope you enjoyed to learn something. As usual, thanks for the super chat or share, like, and subscribe. Patreon, GoFundMe, GitHub, sponsor, and all the other good stuff. Have you ever thought or even did drop support for certain architectures? We do not. No, because we can easily maintain stuff even with older glibc. For example, AVR32. I nearly dropped AVR32 yesterday also, but I got it to build again. It was actually our own inflicted configuration breakage. But I would not delete the source, right? So not supporting it by us by default either means not building it, but leaving all the code in there because some vintage code that doesn't hurt, and like resurrect it and fix it another day. I also, a decade ago, Blackfin DSP stuff built, and we even had embedded projects. We have at least one Blackfin DSP board here in the company even, because that's what we used back in the day. So it's 500, like even this board is old, and even this 15-year-old board is relatively fast 533 megahertz, I believe, BlackFin thing with MMU-less Linux. And we currently, like, it's currently not building because of also regressions and changes. So I'm currently not building it, but I have it on my list, right? So with all your share, like, and subscribe, chances are that sooner or later, like maybe this year, obviously now that 35 build configurations are with this fix hopefully ship worthy and not bug free but bugless, that yeah, we can re-enable all this other fun stuff later, right? Like figure out BlackFin was mostly did somehow not match with uclibc, MMU, ELF binary format things. So apparently 5 or 8 years ago there were some binary format changes for MMU list, whatever. So yeah, basically it wasn't worse for me to debug 2 years ago, so we just don't build it, but the support code is still in there, so that now next week or next month or the summer or whenever we could resurrect it and play pipe via audio or just other audio on the BlackFin DSP, right? Like decode MP3 and OGG and Opus on BlackFin DSP just for the keeping it alive and maintained, or why not? AVR we just use the last GCC and so on where that was in. Ironically, I believe maybe even the latest uclibc version still has AVR32 support. Let's check, do we have an overlay? AVR32 package. Yeah, so I think it was never upstream in binutils and GCC, so we simply have an overlay here of old, and also in the meantime it's deleted from the Linux kernel, so we just use the last known version. It makes no sense, like unless Itanium, the Itanium support community of ours is currently committed to forward ports, so we have the latest kernel running on Itanium, because obviously, right, although deleted in glibc and Linux kernel, we have the patches to restore that, because obviously so much work that our small project just restores it, not a big deal. I hope we have enough resources to forward port Itanium for the next years or hopefully a decade to come. And otherwise, given that it's just metadata, so having some living metadata of last year's CPUs hurts us totally not at all. And it's just, yeah, some attention to detail and motivation to keep that working. I even plan, now that 35 build configurations are in amazing shape, and with today's live stream, even ARM64 in improvements that I was not even aware that it was stupid. My plan is actually to revive every, like my secret plan. Of course, the most important thing is building a microkernel and having other low-level fun with hardware 3D to come here live on this channel really, really soon now. But the other is to revive, like basically my back of my mind secret plan here for world domination, obviously, and YouTube audience is reviving at least one architecture a year until we support all architectures that ever were supported in the Linux kernel. So currently there are some in that we do not support yet, believe it or not. And we will continue, I will continue to enable at least one a year. I'm not crazy to get them all working this year, but like at least one other this year. Maybe I restore BlackFin DSP first, because that was deleted some 3 years or so ago from the Linux kernel. And some other we also do not yet support, so I would need to check which. Maybe Neos 2. I would need to check some of them, like Hexagon C-Sky, like maybe C-Sky. So yeah, like one or whatever is the easiest, lowest. Like I'm lazy, as you know, right? I'm not like I like to work and stuff. So I grabbed the lowest hanging CPU architecture cherry here to cherry pick. And so that ends probably every year at least one build architecture. And some were deleted, like maybe LN32 and also some Renesas, whatever. So, and for that I will not forward part that, I will simply cherry pick the last kernel where that worked. That might be like 5.18 or 6.0 or whatever the case might be for all the architectures, and add an overlay here, right? We have some that we're currently not building, like maybe NDIS32 or some stuff, or Hexagon, or this is the other, like Hitachi 8300, or is this one here, whatever. Chris is also currently broken, so we can easily achieve the coming years over 40 supported architecture combinations with just fixing also Blackfin and maybe even C6X. So yeah, some of those are currently not built. Need some probably easy fix that we will do sooner or later, so that we probably for the 100,000 subscriber special or so, we will probably have over 40 architectures, just to troll the people who say it's so difficult and so much work and it can't be done because whatever. So yeah, stuff is building, stuff is fixed. I have a couple of more changes to sort as usual. It's like there's some stuff in my working copy. Oops. So I'll do this later. It's like 102. So yeah, some stuff is also stupid. Like this. This is a no thing. What was even? This was my thing that it committed. Okay. We can commit this. So I need to clean this up. Also, is it mostly? So this is just indentation that was. This is basically white space. I think it's worth to clean this up. I was debugging something and this was annoying. So this is just a little bit clean up here. Definitely clean line breaks and scripts. Was it function in or no? Functions in. I should have copy and pasted this, but whatever. Slightly clean line breaks and indentation. It's fine, probably. What else do we have there? Scripts. This is a little bit more. Right, theoretically we have here some architecture stuff to what dirty stuff do I right, this is work in progress. This was also disabled. What do I have there even? Risk 5, why do we have that though? Actually this might not be ideal. I have the suspicion this might be a this is entirely not committed. I probably should rebuild this is probably the Mango Pie tree. I should not have built it actually like that. Good that I see this last minute. Risk 5. Never build release ISOs with crazy stuff in here. Working copy. Move Linux to Linux. Mango Pie, I believe. Something of that sort. Actually, I should. Is this Mango Pie or... Yeah, I believe this was Mango Pie. It's not there, it's just... Good, before I forget this, I should actually rebuild it. Oops. Yeah, whatever. Let's mine build risk 564 Linux. And let's rebuild that. Risk 564 to Linux. Nothing like sorting or changes. I have also some changes for, what was it, Spark? Overlay. Spark. A shadow. Spark 32. This new code was simply not building with the old glibc that we use for old-fashioned Spark v8 support. Spark v8 of course deleted. So that's how we maintain this, right? The GNU people deleted, we just It's like, it's not that security relevant, right? Sure, there might be some CVEs as it's Free Software Foundation quality C code, but all right, this other was AVR32 actually. There must be some more stuff. What did we had there? Did we even? All right, this is probably from even today package. Just the usual fixes for like building with old compiler and stuff, like just removing some autological constant stuff, warnings that's not yet supported. And overlay AVR32 glib PCIe tells and with other versions for GCC4. Yes, GCC4. Fixed to Linux to not fixed to just to back up and document everything right. Basically that is hotfixed read line and glib AVR32 tool chain like us. Here just some tiny amount of changes. All right, this Firefox stuff totally wasn't. I can basically delete that. I mean, I could also. I mean, I can leave it there. It does. That's. But some what was IA64 some architecture. Page size. I think this was slightly higher. What was the default? Maybe the default is 64K, I don't know. Default IA64 to okay, pages. Whatever the default might be, that's what we built for the most part. Overlay, open risk, core utils and shadow. This is always for. Yeah, this is UClipC. New versions use too crazy stuff, not building with UClipC at the moment anymore. And basically it's not worth my time to forward port crazy C features. Just old version, it's not primary release, whatever stuff. Yeah, long arch to reverse engineer CCP surveillance tech. Oops. Do we have here? Not really sure I have that there, but in case I'm not really sure, maybe I don't commit this yet, or maybe I review. But here we don't need this anymore. Remove solid arch in utils and Linux header fix. Set bit without this and is fixed in the meantime already. Yeah, this I need to review. Probably didn't build, I guess, or it does now. I mean, yeah, basically I should check if it builds in the meantime, but whatever. Oh, this is not yet commit versi. Don't even remember what it was for. Chris is not yet working, and that is fixing an ICE or an undefined. Disable BK cache FS4 PATCH64 as GCC internal compiler errors with OS at least, maybe also O2, I don't know. But YOLO, don't need this bcachefs yet. On ARch64, maybe someday it will build. Today it's not important. So yeah, fixes, more fixes, and the most fixes, and when you finally thought you fixed enough, then people still find bugs. That's it as usual for this live stream. I hope you enjoyed this and learned something behind the scenes and what it takes to build a all CPU architecture supporting Linux distribution. Don't forget to subscribe. Thanks for the super thank, maybe Patreon. Have a good day and night, and I hope to see you soon for all the next fixes and obscure architectures to support.